This is the fourth video supplement for CIS 343, Grand Valley State University's Programming Languages course. This video discusses conditional statements in Scheme. I'll discuss both the basic if-else construct as well as how to generate what in Java would be implemented as a chain of else-if statements. I'm going to explain Scheme's if-else construct with respect to the ternary operator that's a part of many languages. So let me briefly review this operator for those of you who either haven't seen it or have seen it but don't use it very often. The ternary operator, sometimes called the conditional operator, lets you write a simple if-else block as a single expression. For example, suppose I want to make a statement about your grades. I could do something like this in C using if-else. However, I can condense this down to 2 lines using the ternary operator. So make sure you understand what's happening here. If this doesn't make sense, then Scheme's approach to if-else won't make any sense either. So in general, the ternary operator is part of an expression that evaluates to some value. So let me use this terminology in a more familiar context. 3 plus 4 is an expression. It's an expression that uses the addition operator to produce the value 7. You can draw a loose parallel between the addition operator and a function that takes 3 and 4 as parameters and produces 7 as the return value. The expression here in the second code block has a similar structure. It uses the ternary operator to produce a value of either the string good or bad, depending on the value of the grade. Specifically, this operator works by first evaluating the condition, that's the part to the left of the question mark, and then if the condition evaluates to true, in this case, if grade is in fact greater than 75, then the entire expression, the whole part in green, evaluates to the string good. If the condition's not true, then the entire expression evaluates to the last parameter. So just as the addition operator is loosely analogous to a function that performs addition, you could almost think of the ternary operator as a function that takes 3 parameters. In this case, the 3 parameters are the Boolean result comparing the grade to 75, the string good, and the string bad. This imaginary ternary function then puts the Boolean into an if statement to decide which of the 2 other parameters to return. So why am I pointing out this weak analogy to functions? Well, because Scheme is a functional programming language, and as such, it treats the if-else construct as a function. So let's see how we would write this same code in Scheme. I'm going to frame this example code as a grade report function. That way I can easily rerun it with different grades. In order to follow the same structure as my C example, I want to do something analogous to assigning a value to the variable quality. So in Scheme, that would be binding a value to the name quality, and we do that with let. So our name value pair here, the name is quality, and then we're going to calculate the value. We're not hard coding a value here. So like we did with the quadratic function, what we're going to put in here is an expression that will evaluate to what we want that quality string to be, either good or bad. And in this case, it's not a function, it's the if statement, but it sure looks a lot like a function. So we can imagine this if function has 3 parameters. The first parameter will be a Boolean value, in this case, whether grade is greater than 75. And then the second parameter will be what we want the return of this expression to be if grade is in fact greater than 75. In this case, it's the string good. And then the third parameter is what we want this value to be if the grade is not greater than 75. In this case, it's bad. And then how do we want to use quality? Well, we want to print out a statement about quality. So that's the display. We'll use the format. Check for balanced parens. It all looks good. And then we'll try this 2 different ways. And what is somebody with an 81 and somebody with a 66? Forgot the format argument. What's supposed to go in place of that tilde is quality. Okay, so an 81 is good, a 66 is bad. Let me point something out in case it's not obvious. Remember, I said the first parameter to the if statement is a Boolean value. But what I put up here is an expression. But this expression is a function call whose result is passed to that if statement. The if statement itself is not checking to see if the grade is greater than 75. This expression is executed before the if statement, and that resulting true or false then passed into the if statement. The condition, the first parameter, is not the only parameter that can be a nested function call. The second two parameters can be the results of function calls as well. So let me make up something trivial on the fly here. So I'm just going to play around with some numbers a bit. In this case, the if statement is going to do one of two different things depending on whether the number is greater than 0. So let's say if the number is greater than 0, we want to add 5. And if the number is less than 0, we want to double it. I do this simply to reinforce the point that the result of the condition being true and the condition being false don't have to be hard-coded values. They can be expressions, they can be function calls, and those expressions can be nested as deeply as they need to be. So let's see a couple of examples here. We'll give a positive value for 10. How about a negative 15? And so then when we run the code, the positive number 10 has 5 added to it. You see we get a 15 here. And the negative number, the negative 15, is doubled to negative 30. Okay, so let's go back to that quadratic root function we were writing in the previous video. Now you'll notice that I kind of ignored the fact that not all quadratic equations have 2 roots. In fact, some quadratic equations have 0 roots. For example, the graph of x squared plus 1 never crosses the x-axis. So let's see what happens if we run our function as is on that particular parabola. Let's do x squared plus 0x plus 1. Now that's funny. That just shows that Scheme's smarter than I am. All right, it gave us some imaginary roots. But let's pretend we don't want those imaginary roots. So if there aren't any real roots, we want an empty list. So in this case, the return value of quad root is conditional upon how many roots there are. And if you'll remember, what determines whether there are any real roots or not is whether the discriminant here is positive or negative. If the discriminant is negative, then there aren't any real roots. So we want to avoid repeating ourselves. So let's go back and define the discriminant like we did before. So the result of this function is conditional upon whether the discriminant is positive or negative. So I'm going to phrase it as asking whether the discriminant is less than 0, because I want to do the negative case first. So if the discriminant is less than 0, we want our return value to simply be an empty list. And then if it's not less than 0, we want to do what we've been doing all along. So I'll bring that up here. All right, so now let's see what happens when we run this new version. We get no roots as expected. Now there's one more thing I should do. I should use my discriminant binding here, down here, so I'm not calculating the same thing twice. So let me be careful about this. The discriminant is just this part. Do you see how VS Code has recognized that I have duplicated code and is subtly highlighting that for me? But anyway, so now I can see the part down here that I've already calculated. So I'm just going to replace that with my name. And then let's run that updated code with a quadratic equation that has 2 real roots. So how about -4? All right, and then we get real roots of +2 and -2. All right, so let's think about one more situation. What if we have a repeated root? So to take the simplest possible example, what about just x squared itself? It has a repeated root at 0. So now we can ask ourselves, do we want to see that explicitly? Do we want to see 0 listed twice? Or do we only want to see it listed once? There's not a right answer here, but changing our code to handle 3 separate cases, the case of 0 roots, 1 root, or 2 roots, is a good excuse to demonstrate the other conditional operator in Scheme. This other operator, the cond operator, is what you would use in Scheme when the corresponding Java or C code would be a chain of else-if statements. Perhaps the most common example of an else-if chain is writing code to assign a letter grade to a numeric score. So you can see on the screen how you might write this in C or Java. So let's see how we would implement this algorithm in Scheme. So I'm going to write a new function called assign letter to a given grade. So we're looking for a similar structure for this conditional. The structure being a condition we're checking, followed by the answer we should be giving if that condition is met, but we're going to have multiple conditions. So it'll be a different operation, and this operation is called cond, short for conditional. But like I said, it follows the same pattern. What we're going to have is a sequence of conditions and results. The first condition we're going to check is that the grade is greater than or equal to 90. And if it is, the result should be an A. Similarly, if the grade is greater than or equal to 80, then the result is a B. As I'm doing this, notice that each line, each condition and result pair is a list. At the moment, those lists are delineated by blue parentheses. So let me add the next condition. I'm going to create a list, and the first element of the list is that Boolean value telling us whether the grade is greater than or equal to 70, and the second element of the list is going to be the result. The next one here, if the grade is greater than or equal to 60, that's a D. And then finally, if none of these match, the final else is an F. And we have a keyword for that. Notice the else keyword there is an F. Let me comment out our previous examples, and then let's see how this works. Let's check something that should be an A. Here's a shortcut for just displaying a new line instead of setting up a whole format statement. There's a B. Oh, let's do a D and an F. Let's see if this works as expected. And it does. The 95 is an A, the 81 is a B, the 60 is a D, and the 59 is an F. All right, so let's do one more example. Let's go back to the quadratic equation. So we've handled the cases where a quadratic equation might have 2 roots, or the case where a quadratic equation might have 0 roots, but sometimes a quadratic equation only has 1 root. For example, the graph of x squared only touches the x-axis at x equals 0. As we saw earlier, if I were to run this code as is on the function x squared, I would get a list with 2 values in it, and both of those values would be 0, right? I would see 2 copies of the only root. The reason for that is that quadratic functions with 1 root have a discriminant of 0. And if the discriminant is 0, then the part of the quadratic formula to the right of the plus minus is 0, which means the plus answer and the minus answer are identical. Now, I don't want to see 2 copies of the same root in the answer, so I'm going to add an additional condition to this code so that it shows me 0 roots when there's 0 roots, only 1 root when there's 1 root, and 2 roots when there's 2 roots. And because we're talking about the cond operator, that's what we're going to use to make that happen. So I'm going to change the code up here so that I'm looking to see if that discriminant is less than 0, equal to 0, or greater than 0. And so to handle that, I'm going to change that if statement to a cond. And now we need to make a slight change to the parameters here because, like we saw previously, they come in pairs. In the case where that discriminant is less than 0, I want the answer to be an empty list for no roots. Notice I have to put that in the orange parens here. If the discriminant is exactly 0, then there's 1 root. So in this case, we want our answer to be just a list with a single number on it. And that single number is what's labeled below as the left side, negative b over 2a, because the right side is equal to 0. Now I'm going to bend the don't repeat yourself rule just a little bit in order to illustrate how to use cond in Scheme. If I wasn't writing this in the context of showing you how to use the Scheme cond setup, I would probably have 2 separate if-else statements and then put that second if-else statement inside of the let so as not to have that formula repeated. But given the emphasis of this section of the video, I'm going to go with that cut and paste here. So notice we have our second condition. What should be returned if the discriminant is equal to 0? Let me double check my parentheses here so you can see. So you can see that line 6 begins and ends with an orange paren, and they're both lightly highlighted, which means that they balance. And so then our else condition is the let statement below. So I'm just going to take that paren and move it to the end of the else statement. And again, let's check that those parens balance. So we have the blue parens for the conditional statement, that first let statement that defined, that all looks good. Okay, so now let's run our 3 test cases, and we get the expected answer. The first test case has no roots. The 2 and -2 we saw before. And in this case where we're just checking x squared itself, we have a single root at 0. Actually, let me do one more because testing x squared is kind of a trivial case. So what if we took x plus 1 times x plus 1? That should give us 2 roots at -1. So when we multiply those 2 out, we get x squared plus 2x plus 1. Okay, so we do see that repeated root at -1. All right, that should get you going with conditionals in Scheme. As always, let me know if you have any problems or questions.